Hello students, hello viewers, welcome to Senior College Mathematics. Topic of discussion is algebraic graph. Lesson 1, linear or straight line graph, part 1. Let us examine linear equation or linear function. The general form of a linear equation is y equal to as plus b. Any linear equation has the form of y equal to as plus b, where a and b are constants. Constants means numbers. A can be 2, b can be 4, and so on. The linear function y equal to as plus b has a graphical representation of a straight line. What that means is that anytime you plot a linear equation on the graph, the result is always a straight line whose slope is a. Slope is the rate of change in y to that of s, and also intercept on the y-axis is b. That is the point where the straight line cuts the y-axis. That is the intercept. We have two things to note. If a is greater than 0, this is how the straight line looks like, and if a is less than 0, the straight line falls. The first one, it rises, while the second one, the straight line falls when a is less than 0. Steps in plotting a linear graph. 1. Construct a table of value of y against s. 2. Draw the horizontal axis, that is the axis for s, and the vertical axis called y-axis. 3. Choose an appropriate scale if not given. Very important, you choose a scale. 4. Plot the tabular values on the graph. 5. Join the plotted points on the graph by a straight line using ruler, not your hand. 6. Add the graph title. Every graph has a title, so you remember to add the title, usually using the linear function as the name. You use the linear function as the name. So these 6 steps will help us to accurately plot the graph of a linear function. Okay, you can see a typical structure of a linear or straight line graph. You have the vertical axis, that is the y-axis. You have the horizontal axis, that is s-axis, and the straight line joining all the points together. Anytime you plot a linear graph, this is how it should look like. Okay, this is another form. This point, the 0, is the origin. So from 0 to the up of the vertical axis, the values of y are positive. Then down, the value of y are negative. You can see there they are negative values, while for up, the origin and above, they are positive. Then for s, from the origin to the right, the values are positive, and to the left the values are negative. So when you are plotting and you want to control the table of values, you do it very well and note the values that are positive and the ones that are negative. This helps in drawing the two axes accurately, because sometimes you don't need to draw the axis at the middle like this. It depends on the nature of the values of y and s that you have. As we take examples, you will understand what I'm saying better. Another important term that we cannot skip in plotting graphs is scale. Scale is ordered numerical sequence or arrangement used for measurement. Scale is so important because it helps in ensuring that all the points are plotted on the graph. Very, very important, without omission. When the point values to be plotted are large or very large, scaling helps to accommodate them all in the graph sheet. The graph note above, the one you just saw, is made of several boxes, and each box is called a square. Each square has 5 lines, which represents or stands for 1 centimeter. There are graph notes such that each square has 10 lines. This one is mainly used by WAEC and NECO, which represents or stands for 2 centimeters. So when the square has 5 lines, it means 1 centimeter. When it is 10 lines, that is 2 in 1. So 10 lines simply means 2 centimeters. Therefore, a scale of 1 centimeter to 1 unit on both axes means the difference between 2 square boxes should be 1. So you start with 1, the next box will be 2, the next is 3, and so on. Better understand with the aid of examples. So you follow the voice of Petakus as we journey together in teaching and learning algebraic graph. So we have examples. Number 1, draw the graph of 3s plus 2y plus 1 equal to 0, taking values of s from -3 to +3. So we have solution. This is the linear function that we want to plot its graph. The first step is to construct a table of values of y against s as earlier stated. To do this, note that y is dependent variable, not independent. Y is the dependent variable, and as such it always stands alone on the left hand side of the equation. Y is the dependent variable and it stands alone on the right hand side. That means you have to make y the subject of the function. That is the meaning. So we have the function 3s plus 2y plus 1 equal to 0. First, you need to make 2y the subject by transferring plus 3s and plus 1 to the right hand side. So you have 2y equal to minus 3s minus 1. You divide through by 2 and you have y equal to minus 3s minus 1 all over 2. And you know minus 3s and minus 1, they have equal access to 2. So you can split it to minus 3s over 2 minus 1 over 2. So we have to use this final result to construct the table of values. All right. From the question, the values of s ranges from minus 3 to plus 2. So this is the table now. You have it in a row form. So the first row is s, and the values are from minus 3 to plus 3. For us to look for y, we have to do two things. That is getting the value for this, and we already know this as minus 1 over 2. So we look for minus 3s over 2. So when s is minus 3, what is minus 3s over 2? It simply means minus 3 over 2 times minus 3. That is plus 9 over 2, and that gives 4.5. So when s is minus 2, you have 3 for minus 3s over 2. So when s is minus 1, you have 1.5, and so on. Minus 1 over 2 is a constant because it has no s. So that constant is common all through. So you have 1 over 2 is 0.5. So you have minus 1 over 2 becomes minus 0.5. So you write it under each number for s because it is common all through. So for us to get y now, what we need is minus 3s over 2 minus 1 over 2. So when we come here, we simply have 4.5 minus 0.5. That gives the first y value 4.0. Then we have 3 minus 0.5. That gives the second value 2.5. Then 1.5 minus 0.5. That gives 1.0. Then we have 0 minus 0.5. That is minus 0.5, and so on. So the next step now is to plot the values on the graph sheet. So you have the table of values, but what we have here now is just the row for s and y. What we have previously is to explain how you get y values from s using the linear function. So we have to choose a scale here. So this graph you have here now, each square is 5 lines. That means we can use, so each square is 1 centimeter. That is the meaning. So you look at the values of s and y that you have, the available space, then you choose your scale. So here my scale is 2 centimeters, represents 1 unit on both axes. When you are doing this, it is important that you know what one line stands for in case of decimal value that you have now, decimal values. So this K implies that one line is 0 0.1 units on both axes. Note the graph will fall because a is less than 0. Okay, so you can see here, this is one square now, and this is the second square. So my scale states that 2 cm, that is, I should combine two squares and give it 1 unit. So you have 1 2 is 1, the next 1 2, that is this and this becomes 2, the next 1 2 is 3, the next 1 2 is 4, and so on. So from the origin here, up of y and right of s, you have positive values. From the origin down of y and left of s, you have negative values. The next thing is to plot. The first point there is when s is minus 3, y is 4. So this is minus 3 for s, and this is y. This is 4 now, 4 for y. So you trace the point. This is the point of intersection. So you put asterisk or a dot at that point. The next value, when s is minus 2, y is 2.5. This is s here. When s is minus 2, now 2.5 is between 2 and 3. Remember, we said that one line implies 0.1. So this is 2. After 2, the next line becomes 2.1. The next line 2.2. So when you count 5 lines from 2, you have 2.5. That is somewhere here. This is 2.5. You trace it to minus 2. This is the point of intersection. You asterisk it. The next value is minus 1 for s, and y is 1 as well. So this is minus 1 for s, and this is 1 for y. The point of contact, you mark that point. So you go on in that order until you get to when s is 3, y is minus 5. So when s is 3 here, y is minus 5. This is the point of contact. You asterisk it. So you've plotted all the points on the graph. And of course, the title is there. The title is the name of the function. It's not any other name you import from anywhere. The name of the function can serve as the title of the graph. So clearly the straight line fell because a is less than 1. So the next thing is to join the points together after plotting them. So this is the final result. So with your ruler, you join all the points together. So after doing that, you see that it is a straight line graph, as we explained earlier. For every linear function, the graph is always a straight line graph. Hello. End of lesson 1. Thanks for watching and learning. Don't forget, watch out for more from the voice of Petakus. If you are not safe, your life is in crisis. To avoid that, you give your life to the one that can save you, and that is the Lord Jesus Christ, and you confess him as your Lord and personal Savior every day of your life. If you are saved already, congratulations. Live righteously and be prepared, because on the last day some will be taken and some will be left. Take good care of yourself. Stay out of trouble. Study your books. Do the needful at all times. Flame every appearance of evil. Don't defraud others to make money. Use your hands and your brain to work genuinely and legally, and the Lord will bless you. Goodbye.